yesterday's stuff. That one is this. Just to make sure that we are good to go with what we did yesterday. Calculators for sure, so have a phone out or a calculator, whatever. It's going to be easier for you. Just so we can do this really quick idea, okay? But before we do that, are we good? God, I haven't seen you since Thursday. We've done 2 different things since then. Like, are we okay? Let me back up even more. With lesson 3 stuff, like the breakdown of what this normal curve looks like with this thing out of the way. 68, 95, 99.7. Because that's what we need to be able to understand. Now, you don't have to know that by heart, but it does make your life a whole lot easier if you do. Really, the thing that we want to make sure we're good with is that if like from here to here is 68%, that means that each of these pieces is just half of those, kind of broken up. And every single section has its own like little chunk of where the percentage of that data is going to lie. Now, this is only if the data looks like this, right? You've got this one nice big peak in the middle and everything's normal. And this is approximately, this is not perfect. Almost nothing in real life is actually perfectly normal, but it's pretty darn close, right? So 68 from there to there, 95% once we go out 2 full standard deviations, right? And then 99.7. Almost all of it within 3. Okay, and that's what we looked at on Friday. And I know you guys weren't here for that. But what that did is we like focused on the little chunks and we got these like super easy, really nice sections, right? So from there to there, 13.5. From there to there, 13.5. And it was like 2.35, I think, was that section. Same as this one. Just that little 2.35, that little tail right there. And that's almost everybody. Right? Add that all up, 99.7. Right? And knowing each of those chunks is going to make it a little bit easier for us. And you're going to see why once we get to lesson 5 as part of today. And then this super tiny little piece down here was 0.15%, like almost nobody. Those are your outliers, way, kind of far away, right? Where your average is floating in the middle, okay? When we were doing box plots, it was the median, right? We just lined them up from this to greatest and we looked for the middle one. This is all about where the average is. Do you remember what I said it last couple of days? I know we weren't here, but if you caught it, what is that thing that I circled? What's that Greek letter? Do you remember? This one down here. What's the like the name of the average? Sigma is the other one, yeah. So this is sigma, right? What's that one mean? What does that stand for? Standard deviation, same starting letter. This one, that's your mean. So it's the same first letter, M for mean, M for mu. Nice. Mu, that's a fun math word. So average, mu. Mean, mu, same letter. And then standard deviation. And that's the idea is we're going to go like one standard deviation above, and then another, right? And we're going to go one below, and then another, and then another. And all we really needed to be able to do with that is like start thinking about how we can use it to do this. And this was yesterday, okay? So I'm happy to go through this. Now that we've got like, oh, here's all of the data and it looks awesome and it's all spread out and everything's even and perfect, cool, I can look at all of the data all at once, but maybe I want to look at a specific spot and figure out how it compares to everything else. Right? Kind of looking at all the data all at once is really nice if we're thinking about everything, but there's a lot more to this. And part of that can be, all right, let's look at actually one single point and see how it compares to everybody else, okay? And so when I talk about a point or a person or a value or whatever having a Z score, all that means is what we did yesterday. It's figuring out how many standard deviations it is away from the average. Am I the average? Am I 1 standard deviation away? Am I 2 standard deviations away? Am I -3 standard deviations away? Depending if I'm more or less, could be positive or negative. Am I 1.3 standard deviations away? Whatever it is, that's called a z-score, okay? And knowing how far away you are from the mean tells me where I'm going to fall potentially within this whole range, okay? And so that's what we did yesterday is we looked at this, and there's a super simple formula, and it's this one right here. Your z-score is just that. Whoever you are, whatever your value is, take away the average and divide it by that standard deviation. And what we did yesterday is I'll go through a couple of these just so you get the hang of it, but it's not bad at all. But sometimes I need the calculator to help me. What I need to be able to do first is draw this picture. Okay, and a lot of times they'll draw that bell curve for us, which is really nice. And they put that dotted line there so that we know exactly where the middle is. Because what number is always going to go in the middle of that bell curve? What's the center? The mean, good, the average, right? And so I have to kind of find that, and they kind of bury it in here somewhere. Oh, there it is. The mean is 24. And so I always start by dropping the mean in the middle. And what this bell curve does, what those tick marks do, is it takes us a standard deviation at a time. And now that we've done the standard deviation by hand, we don't have to do that again until maybe we do it for the final project. But now they're just going to give it to us, right? They're going to tell us, oh, the standard deviation, that's 2. Right? And that tells us the numbers are pretty close together, right? Most of the numbers are kind of within 2 above or below. In fact, 68% of them on average, right? 68, 95, 99.7. And so that's what I can do. I can go up 2. So like that next spot on here is 26. And then you go up 2 again. Sweet, 28. And then you go up 2 again. And that takes you 1, 2, 3 standard deviations above. And then you can go below. -2, -2, -2. Once you get the hang of that, knowing that the first thing I'm always looking for is just tell me the average so I can put it in the middle. And then let me know what that standard deviation is so I know how many I have to add and subtract when I move up or down to get to those spots. Cool. Now, all right, well, what's the point of doing that? Well, it's all about focusing on just one specific number and trying to figure out where that is on this graph and come up with a z-score that makes sense. So what I want you to do, like, if this is our graph, I think that's going to be really helpful is to try to find that number. Like, where is 27, all right, 24, 26, 28, they're right in between. And what we want to figure out is, okay, that's where 27 is, right? That's what we're looking at. Maybe we're looking at ACT scores, right? Maybe here are all the ACT scores for the graduates of 2021. And we want to compare a single person to everybody else, all right? And kind of feel like, all right, these are my grades. This is how I did. Let me see kind of where I fall so I know what I got going on. So I have expectations for what I can do. Well, what do you think? What do you think that z-score is going to be? And let me preface this by saying, remember, every one of these tick marks represents 1. This is 1 standard deviation, and then another, so it's 2, and then another, that's 3. -1, -2, -3. 1.5, right? There's 1, there's 2, it's right down the middle. And so what that should give me, that 1.5, it should tell me how many standard deviations I am away. And here's how you do it. You take the value, okay, that's 27. You subtract the average. And the order is going to matter there because with subtraction, you could get a positive or a negative, and that'll just tell you what side you're on. So we could get positives or negatives, that's no big deal. And then divide it by that standard deviation. And then I just see what I get, right? Some of this stuff you can do without a calculator. Some of it you might need it. 27 minus 24, that's not too bad. I can do that. That's just 3. And then 3 over 2. And we're always going to write the decimal. Okay, and this is exactly 1.5. So I can say equals and write that 1.5. And that's all we tried to do yesterday. It's like, okay, what are these graphs going to look like? How do I draw out these bell curves and actually mark them up so they make sense? Put the mean in the middle and then just add some standard deviations and subtract them as you go. But then locate the spot and try to figure out what this number might be before I actually plug it in. And then today, I'll show you how we're going to use these z-scores to figure out your probability of where you're going to fall. Okay? Are we cool with that? Should we do one more? Maybe it's a little bit trickier because it's got some subtractions, some negatives and stuff. So let's do it. I'm going to, if you guys are good, I'm going to erase so I can scroll. Let's do number 2. Okay. What is the z-score? So, in other words, how many standard deviations away is 104.5 in some set of data with, what's that weird looking mu? The mean, and how do we say it out loud? Mu, nice, mean mu, good. So we have an average of 125, and what's that O with a little thing on top? Sigma, nice. Pick a Greek letter, right? Hope you get lucky. What does sigma stand for? Sigma. Subsequent division. You got the first 2 letters, right?
Standard deviation.
Standard deviation, good. Okay, so what goes in the middle then? Always, always, always. What am I putting at the bottom of that dotted line? Because we got to draw the picture first. What goes in the middle? 125, the average. Now, these numbers, maybe because they're a little bit bigger, you might want to like tilt yourself, write them sideways, so you have some space. I like to switch colors every time so that I can read it really well. But, oh, geez, I gotta keep back, go up a standard deviation every time. And maybe you can do it in your head, but maybe you just want to be safe. All right. I got to take that 125 and I have to add that standard deviation to 6.2. And so that's what I'm doing. Okay, so 131.2. And then I do it again, right? Plus 6.2. Okay, cool. 137.4. Okay, cool. Do it again. 143. So that's plus a standard deviation, then plus 2 of them, and then plus 3 of them. Now I'll go the other way. So I'm going to clear it out. 125 minus 6.2, so I can start moving to the left. 118.8. Do it again, minus that 6.2, right? So I started here, subtracting or adding these every time. 112.6. One more. 106. There it is. And that's kind of all I really need to get started. Mean goes down the middle, plus, 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 minus, minus, minus. That's all I need. And obviously, there's some stuff, right, that's out here, but not much, right? Literally, like 0.15%, super, super tiny, same thing on both sides. 68, 95, 99.7. Now, but it's all about focusing in on 1 point and 1 point only. Where is 104.5? Tell me where to stop when you think I should be at 104.5. Right there? Yeah, that's pretty good. All right, 106.4. All right, got to do a little bit less than that. And so what do you think the z-score might be if, like, in my mind, like, that's 0 right there, right? That's 1, that's 2, that's 3 standard deviations away. What do you think we're going to get? But we got, so that's positive. We got to go negative. Negative 3.5. That's a pretty good guess, right? Negative 3 point something, probably. let's prove it. Let's figure it out. So we got to do z equals. No, that's good. No, I want you to do it, right? Value. So 104.5. Sounds like I'm talking about a radio station. Minus the average, 125, over the standard deviation, 6.2. Negative 20.5 up top, okay, over 6.2. And then what happens when you plug that in is we get some long decimals, right? Those don't go really all that nicely into one another. So let's see. Negative 20.5 divided by 6.2 over 2. Okay, so it goes like this, right? Negative 3.306451, blah, 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 blah. We don't need all of it. Okay, that's a pretty good guess at negative 3.5 though, Jay. That's pretty close. Now, what we need to do, always, 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 if we have to round, 2 decimals. That's plenty, okay? And so in my mind, I'm kind of like putting a brick wall right there and deciding what the best way to round. So approximately what? So if we're going to round, it's nice to put that little squiggly equal sign. So we know we rounded. All right, so negative 3.3, and I got to figure out what that second decimal is. Should I keep it as a 0, or should I bump it up to a 1? 5 or above, give it a shove, negative 3.3. That's my z-score for that value. That kind of makes sense, right? The average is 125, standard deviation is 6.2. Look how far away it was. Might even be an outlier, realistically, depending on how the data shakes out. That's how far away it is. We know it's less because it's negative. And then we have negative 3.31, way, way, way down there. Not bad, right? Once you get the hang of it, it's really not that bad. I like it too. I like it too. I'm glad you like it. I mean, I don't know if you really want to see more of those. It's the same thing, like over and over and over and over and over again. It's just kind of messing with some of the numbers. So if you're good with it, I'd like to just kind of like push it on a little bit and let you kind of finish it on your own, unless you want to see another one. You tell me. Third one, just to be safe. Let's do it. So let's skip the cow. We'll skip the cow. Because that one, I think, was a pretty similar one. Actually, I did all these answers. I want to take a good one. Where's my answer? Kaylin, where'd I do it? Where'd it go? Kaylin, you were supposed to keep track of this one. Right here, Kaylin. Come on. So yeah, the number 3 was like negative 4 point something. Let's do, gosh, I don't know. Let's do number 1 on the next page. How about we do that? Let's do this. This is eventually what we'll do is let's just start looking at some data that we find, like our unit 2, a whole normal distribution kind of project at the end. We'll get some data, but we'll just make sure it looks like this. Right? We're not going to get weird left skewed or right skewed or multimodal or whatever. Okay, cool. Scores on a history test has an average of an 80 with a standard deviation of 6. What is the z-score for a student who earned a 75? Okay, so we got to draw the picture first, right? Step one, step one, step one. Always, always, always draw that picture out. So what goes in the middle? I know sometimes like they put the mean first or second or third. You got to watch out. We got to find like it says mean, it says average, or it says mu. There it is, 80. And then what are we supposed to add and subtract every time going up and down? 6, good, standard deviation. Boom. All right, so there it's going to go up 6, so 86. I can do that. Plus another 6, 92. Plus another 6, 98. So someone you can do in your head, but of course, calculator if you want to be sure. There's no shame in making sure you're doing it right. And then minus 6. Minus 6. Minus 6. And before I even calculate the z-score, I like to kind of see if I can find where my number is going to be, right? So there it is, right? We're looking at one specific person, in this case, actually a person. Some student got a 75. He's trying to figure out kind of where they fell amongst everybody else. So let's find 75, or well, it's not exactly on here, so but I can guess. 74 is right there, 80 is right there. So I'm going to be pretty close to 74, but just a little bit more. Oh, that line's all sideways. Right there, something like that. And so what do you think? First of all, is it going to be positive or negative? Negative. Because it's to the left. Perfect, right? Because this is like 0, right? Right on the average. 1 standard deviation, 2 and 3, -1, -2, -3. But what do you think? Is it going to be like between -3 and -2, -2 and negative? What do you think? Pretty close to -0 point something, right? Got to be negative because it's to the left, but it's not quite -1. Something like that. Yeah, 0.9, 0.8, something like that. Let's figure it out. Z equals. And so just having that foresight, I think, is going to help us a lot with this next one. I think if you've done this already, thank you for waiting. So 75 minus 80 over 6. The value minus the average over the standard deviation. X minus mu over 6. Good. Now, I don't know exactly what that is, so I'm going to jump in my calculator. And see what I get. If I get something perfect, then I'll just use it. But if I get some decimal, then we'll round it. -5 divided by 6, yeah, some decimal. So it is that 0, so -0 points, that was good. 8, 3, 3, 3, 3. So this is going to keep going. So I don't want to do that. I only need 2 decimal places. So -0.8. Keep it a 3 or bump it up to a 4. Right? 5 or above, give it a shove. Well, it's only a 3, so I'm going to keep it the same. There it is. There's a z-score. -0.83. So not quite a full standard deviation below. Okay. Here's why we round to 2 decimal places. Go ahead and turn the page. Now, if you were good yesterday, here's where new stuff begins. Okay. At the top, you'll see it says Unit 2, Lesson 5. Now we're going to use these z-scores. Let me pull up something, and people at home, if you want to check this out, the easiest way to get there is to look at today's announcement, because there's actually 2 things that we need to be able to do this lesson. Okay? And these 2 things right here. The actual notes, which you're looking at right now with those bell curves that actually are all shaded, right, in different sections. But go ahead and turn to the back page just so you can see it. Okay. Front and back of that last page. Okay, that's called Table A. And that's not me making up that name, okay? It is the first table in statistics, okay? And it is the easiest way to do this, okay? And so I'm actually going to open it up on here so I can go back and forth a little bit. What I want to do is kind of break this down, okay? What we can do with z-scores is not just figure out, okay, how many standard deviations somebody is away from the average. But we can start, remember, this is probability and statistics. We can start talking about probability and what the chances are that somebody falls within a certain section. And usually what we do, the easiest one, is to say, okay, if this is my z-score right here, I can figure out the probability of somebody falling in the space less than or equal to. So sure, he's got a z-score of -0.83, but what are the chances that somebody is in the section with that z-score or less? And that is what you are seeing buried in this kind of daunting, I understand, daunting table, right? The front, that first page, look at this. negative z-scores on that first page. Yeah, everything from negative 3.4 all the way down to nothing, right? Back to the average, okay? The second page, I don't know why it's not lined up the same way, all the positives, okay? But what I need to teach you first is how to read this table so we can get to the right spot. Because you can see that there are rows and there are columns that are all about the z-score. Because how many decimal places are we always going to round to? 2, right? And so what this first column does is it gives you just the first one, right? 0.6, 1.5, 2.2, whatever. But if you want the second decimal, that's what these numbers up here are going to do. And so if you are looking for, let's say, and let's do the last one. I know it wasn't even like we won't even start this one, but that negative 0.83. Check this out. If your z-score was negative 0.83, right? So it was that person that just scored a 75 in the test. If we wanted to figure out what the chances are that somebody scored a 75 or less, this table can do it. And here's how we do it. We have to find where the first decimal and the second decimal meet in the middle. So the first thing I do is I find the first decimal. Negative 0.8. Find it. See if you can find it. Because this is going to be a lot about you knowing how to read this table and finding where the right row and the right column intersect at one of those 4-digit numbers. So there's my negative 0.8. So this whole row that starts with that 0.2119, 0.2090, 0.2061, like all these numbers in that row, all have a first decimal of negative 0.8. But I don't want just any negative 0.8. I want negative 0.83. Right? That was the z-score for that last problem we just. So this is your first one. These are all your second ones. So that's why it just has a 0 there, but it just means don't look at the first one, look at the second decimal. 0, 1, 2, 3, 4, 5, and like that. And what we need to do, and you don't have to draw this, but I'm just going to help you see it. We look at that row, the negative 0.8. This column with the 0.03 to get that z-score. And it's the one where they meet. And so what you're going to do is probably like what I always do is I just kind of like follow them with two things. Like one going across, one going down, and I meet in the middle. So I go like this. Okay, negative 0.8, 0.3, and there it is. Okay, the 0.2033. Now, what the heck does that mean? 0.2033. That is 20.33%. That is the probability. What are the chances that somebody on that test scores 75 or less? And it's all about that or less, okay? That number is always, and look at what it says here, right? The area under the standard normal curve to the left of z, less than your number, okay? And what we're going to do today, probably tomorrow too, is learn how to do that. Okay, but that was my first example. Let's do it. Let's do it. So I'm going to have to bounce back and forth between this and this. And I got to open it up. And this. All right, here's what's sitting in front of us. Okay, and there's a link to table A right there. And if you need, like, if you're like, dude, I don't know what you're talking about, and in the next 20 minutes, you're still like, dude, I don't know what you're talking about, there are QR codes that you can put on there if you want some help, some extra guidance in trying to learn how to read these z-score tables. So, take a look. Calculate that z-score first. what we can do is we can figure out what the chances are of that number happening. Okay? What the table does is it gives us the probability of getting that or smaller. Okay? So that table A can get us some values. And so here's the nice part about this lesson. I'm not going to make you calculate the z-score over and over and over again. Just like I didn't make you calculate the standard deviation over and over again, right? Now we know how to do it. Now they're going to give it to us. Let's take a look at number one. Use table A, so that's that big table front and back, to calculate the probability that a value with the z-score less going to occur if things are normally distributed. So that's my number. That's the number that I'm looking for. And look how many decimal places it has. 2. Always. Because now what I can do is I can turn to this table and look for that z-score. The z-scores are on the outside. The probabilities are on the inside. Now you see that it, like, I took the number 0.2033 or whatever it was, right? And I called it 20.33%, right? Percentages always move that decimal place 2 spots. Because the area under this whole curve is 100%, right? It's everybody. The area under the curve is 100%. And what I'm trying to figure out is give me a z-score that looks like this, right? 2.47. So what they're doing is they're kind of going like this. They're saying, okay, there's 2.47 right there. But I want to figure out what the chances are of somebody getting that score or less. So looking at like all of that area underneath that curve, that's why it's shaded like that. Because remember, 68, 95, 99.7, right? That's the percentage of the population that is under that curve in each of those sections. All right, so my z-score is 2.47. That's my number. And what I'm trying to figure out is some probability of that taking place. And so we jump to table A. We say, all right, 2.47. Well, I got to figure out what side I'm supposed to be on. First side is all your negatives. I don't need the negatives. I want to go to the positive side. So I flip to the back. Okay? And the way that we read this table is we find like kind of your first number and the first decimal in this column. Remember, we're looking for 2.47. So I got to look for 2.4 first. Okay. There's 2.4. And you can see that those numbers in this highlighted column are all really close, but they're just off by a little bit. And that little change is just whatever the second decimal is going to be. Is it 2.40, 2.41, 2.42? No, it's 2.47. It's this column right here. Now, if you mark this up, and you're like, man, I wrote all over this. I'm probably going to need an extra copy. I got tons of copies. So if you want to write all over it, do it. I don't care. But you'll see that pretty soon it's going to get kind of messy. And so if you can do it visually, that'll probably help you. But look at where they meet. That's all I need. I want that number right there. The spot where the column and the row and column, meet for 2.4. That makes sense? How to read that? Cool. And there's my number, 0.9932. Okay. That means I go back to here, 0.9932. And honestly, that's okay. That is the probability. You just have to know that it's out of 1, really 100%. So if you prefer percentages, then just move that decimal 2 spots and call it 99.3. That number kind of makes sense, right? Because remember, from here to here was 68. From here to here, 95. From there to there all the way was 99.7. Well, we're just a little bit less than that. which is why we got the 99.2. And honestly, like the biggest part of this is this word right there. Less than. That's what makes this table easy to read. Because that's what this table is designed to do, is to give you the probability of that number and everything less than that. And so you're going to see that once we get a little bit further into this, they're going to mess with our thinking, and they're going to say greater than or in between. We have to kind of think that process. Cool? Okay, let's do another one. Let's do 2. I'm going to erase some stuff. 99.32. Okay, cool. Here we go. Use table A. Okay, I know what I got to do. Calculate the probability of a value of a z-score. There it is. I feel really good when they tell me less than, and they draw the picture to kind of match that, right? There's, gross. There it is, about negative 1.23, whatever. And they shaded all of the space less than that. And so what I'm trying to figure out is what are the chances that, I look at everybody and whatever this data is, and I randomly pick one that falls in that spot. Whatever it is, right? Whatever data we're looking at, if I just kind of lay it out, right? I put it on a dartboard, I close my eyes, and I just throw a dart. If I hit it, what are the chances that I hit in that spot? That's really what we're looking at. And that's what table A can do. It can give us the probability. Okay, negative 1.23, that's my number. I got to pick the right side. Well, we were on the back page with all the positives. That's no good. I got to get on the negative side. So what did they want? It was negative 1.23. I've been saying 3.2. Okay. Negative 1.23. See if you can find it. See if you can find the right row and the right column. Knowing that that first row is just going to be the first decimal, right? Of course, the correct leading number. And then the last thing we have to do is find the right column for that 3D. Right, negative 1.23. Okay. Negative 1. You can see that they try to shade it to make it a little bit easier to read because there's a lot going on. So there's my negative 1.2, so it's got to be one of those numbers. I've got to pick the right one. This. Really. I see some weird looks. Talk to me. What about this process doing? I mean, because reading the table is priority number one. You got to be able to get yourself to the right spot to stand a chance at any of these questions. And these are the easiest ones because that's my answer, because it was just less. We'll do that one next for sure. Yeah, I wanted to make sure we at least got to a greater than one today. But you see how I had to recap some stuff today? I'll probably have to recap some stuff tomorrow. So thank you guys for giving me the time to do that. Are we good with that number right there? That's good. Okay, so are you good just getting to that number? Okay, cool. So let's go back to our sheet then. What was the number? 0.93. So it's let me see how I can see this. Okay. Empty hat, door block. I wish, right? Okay. It's the only thing in it. What are the chances that I reach my hand in here, pull something out, and it's a wooden door block? What are the chances? 100%, right? How many of these are there? 1. Those two numbers are the same. The number 1 and 100% are the same number. Are we cool with that? Okay, because you have to get that to make sure. Because so percent out of, right? Right? 50 miles per hour. 50 miles out of, yeah. How many cents are there in a dollar? How many years are there in a century? So when I say percent, I really mean out of 100. Okay? And so when I say 100%, I mean everything, right? That's 100 out of the 100. But that's what I'm really, 100 out of 100, right? 100 divided by 100. These numbers are the same. One has a percent symbol, the other one doesn't. Decimal places, 0.00. And so, Maddie, to try to answer your question kind of a long-winded way, this is your probability. It's just written as a number, 1.00 rather than 100. And so, honestly, like that's good. That is the probability. But for me, I understand percents better than I do decimals. And so what I usually do is I slide the decimal points 2 places. Give me that percent. Because like this is like out of 100. Well, sorry, this is out of 100. This is really out of 1. Okay, out of 1, out of 100. I just understand percent. Like my mind, 10% makes more sense than 0.10 as being like how much. Does that answer your question? No? All right, let's do one more at least. Because this one is just a little different. Okay, use table A, or I know what I got to do. I know what I got to turn to in a second. To calculate the probability that a value with a z-score of greater than 1.5. Okay, so there's my z-score right there, right? 1.57. But when I jump to table A, it's going to give me z. It's going to tell me all of that probability. So let's just do that. Let's figure out what's in the red space, and then we can use that to figure out what's in the space. Okay, so the story is printed. What's our magic number? 1.57. All right, find 1.57. All right, I'm on the negative side. So let's switch back to positive. And I don't do that whole highlighting thing every time, but I do it in my mind. Like I go like this. Like I know what row I'm in. I'm in that row right there with the 1.5. Okay, that's the top row, kind of grayed out section. And then I'll just find the next number. Okay, 1.57 is that. 0.9418. Right, 1.57. 1.57. Okay, so there's that number, 0.9418. So I'm going to do it in red. So here it is in red. So my red number, all of this space, all down here to the left of this, what is it? 0.9418. Okay. But that's not the number I want. That's this number, right? Chances of me with the blindfold, go in the dark. Dark's a little weird because it's not just a circle. But you know what I'm talking about, like just picking out a number. I don't want that. I want the number in the blue space. Okay, well, if you want 94.18%, that's the chances of you falling into the red spot. That's not what I want. I want the blue. And so if the chances of, here, let's do it like this. I don't know if this is going to help, but I'm going to drop 2 things in. We're blocking a pencil. What are the chances of me picking up a pencil? 50%, right? 50-50. Okay. Okay. So the chance of me picking up the pencil were 50. Well, then, what are the chances of me picking up the wood block? The other 50%, right? Okay. Four things. Purple pencil, yellow pencil, marker, door block. What are the chances of me taking out the door block if there's four things in here? 25%. So what are the chances of me picking up the other three? The other 75%. 50-50, 25-75. What are those total no matter what? 100. And so if I know that the red space is the 94.18, I just want the other piece that gets me to 100. I want the difference between. If you're doing percentages, then do 100. Here, let me actually do it both ways. I don't care which way you do it. I like the percentages. I'm going to probably stick with that most of the time. But if I'm doing percentages, it's 100 minus 94.18, and I'll see what I get. If I'm doing it with the numbers, without the decimal, without the percentages, it's 1 minus 0.94. And I see what it is. 5.8, sorry, 2, 2%, which must mean that this is 0.058. Okay, so if you're doing less than, boom, table A, piece of cake. Okay, if you're doing greater than, either 1 minus your decimal or 100 minus your percent, because we're just looking at the difference. I'm glad that hat analogy kind of worked. I really I started that and I was like, I don't know where I'm going to take this. Like Michael Scott, sometimes I just start a sentence and I don't know where it's going to end up. All right, let's do one more because we got a second. Because this is another greater than one, so I think this will help. I'll leave that up for a second. All right, cool. Greater than. As soon as you see greater than, I know I have a little extra work that I have to do to get there. Because if I go like this, right, negative 2.03, my table A is going to give me all of those numbers. Everything less than. I don't want less than, I want greater than. But I still kind of start with that. I jump into table A, I see what negative 2.03 is going to give me. All right, now I got to erase some stuff. So back to the negative, so back to that first side of the table. Table A, negative 2.03. So where that row and that column meet are right there. Negative 2.03. Okay, so 0.0212. So right there in red, 0.0212. Or move the decimal 2 spots, 2.12%. That is not the number that I want. I want all of this. I want all that blue over there. So pick your style. Pick one. Don't do both. Just pick whichever one you like. You like the decimals? Great. You like the percentages? Cool. 1 minus or 100 minus, depending on which one you do. 0.0212 or 2.12, and you see what you get. Either one, pick your favorite. What do you think? Okay for now? So we will pick this up tomorrow, but what you're going to see me do tomorrow probably is recap this stuff with cohort A. So that'll give you a little bit of downtime to start a class, but also a chance for you to be like, okay, that makes sense. Yep, I remember that. You just kind of float along with me until we get to the next page, and we'll start doing the in-between. All right, so take that home with you, and I will see you guys online tomorrow, and then, of course, in person on Thursday.
Rosie, do we have to turn anything in today?
Nope, nothing to turn in today. You are good.
Okay, thank you.
No. You just tell her she's my girl.
You guys, thank you all.
Thank you, brother.
Thanks, Charlie.
Thank you.
What do you think? Makes sense? So far?
Oh, yeah, that analogy helped out.
I didn't know, like, I was like, I gotta figure out
I'm not
something
good
to
with
like talk about probabilities, right? Yeah. We haven't talked about
Thank you.
You're welcome, thank you. So this is just kind of like a little bit of preview. I think like after spring break, we'll start like just probability. Drop statistics and start talking about. All right,
Good job, bro.
huh?
Great guy.
Why don't we do that? Like 2.5 weeks. Crazy, right? Yeah. So this is the week of the 22nd. Then we have the 1st, the 8th, and then spring break. Hey, what's up?
How much?
Later. Connected. Some statistics for anybody taking AP Stat next year. We just did some. I'll stop recording. You guys are good. See you tomorrow.